Okay, so welcome back everybody. This video is how to program a STM microcontroller. So what we're going to do as a starting project is we're going to generate a 100 kilohertz square wave, like PWM, on the pin. So the way we're going to do that is we're going to go into STM32. We're going to generate the code in there, and then we're going to import that code into the IDE. Then we're going to activate the timer, and then we're going to verify it works on the oscilloscope. So let's jump into MX, and then we will go from there. So we go to board selector, we select our type, which is mine's a 32. We select our series, mine's an L4, and then it comes up right here, KC. Okay. Yes, we're going to analyze all the peripherals. It's going to load. And then we're going to, so now we're here. Okay, and as you can see, we have the chip. And our goal here is we're going to make a high frequency PWM for a boost converter. So I'm going to select PA9. You can select any of the pins that has a timer on it. I'm going to select timer 1, channel 2. All right. And now that's selected, or that's initialized, we can come over to timers over here. Yep. For clock source, we're going to do internal clock, and we're going to enable PWM on channel 2 because it is channel 2, and that goes green right there. We got the tick of approval. We are flying through this. Okay, so now it comes down to our frequency and our duty, which is going to be our pulse. So I'll do the pulse first, which is going to be 80. These values are for a 32 megahertz clock speed. So this one's 319. I will put the equations at the end so you can set whatever duty you want, and you can set whatever frequency you want. You can go pretty high with the STM32. Just one thing to note also, if you're wondering where we see, what our base clock is, we come over here to clock configuration, and I'll just bring your attention down to this branch here. You can see MSI is selected. It's multi-speed internal clock, that's what it stands for, and you can see up here in the drop down menu it's set to 4000 kilohertz, which is about 4 megahertz. Okay, and it comes through the PLL source mux, which is a phase lock loop, and this is going to allow you to change the clock speed. As you can see, it's divided by 1, multiplied by 16, and then divided by 2, which is going to give you a phase lock loop clock speed of 32 megahertz. Okay, so we don't want to change the AHB prescaler, which is an advanced high speed. Oh, I forgot what the bus. Oh God, I forgot what it stands for. Anyway, you don't want to change the prescaler here. This will just slow the whole system down going forward. The one you would want to touch is the advanced high performance peripheral bus prescaler 2, which is going to control the clock speed of the timer that we have. But we're not going to touch it. We're just going to get a clean 32 megahertz on our clock. Okay, so again, I'll put the equations at the end of this video so you know what counter period or auto reload values you need to select whatever frequency you desire. All right, so now what we're going to do is we're going to go to Project Manager. We're going to select a project name, and I've just selected this as a name. It can be anything. Now, the one that you don't want to get wrong is the toolchain IDE, which is down here. Do not keep it as EWARM. Make it STM32 CubeIDE. If you don't do it, it'll give you a lot of trouble, and you'll be pulling your hair out. So that's that one box you need to do, and then you can do generate code. All right, so that's going to generate, and there we go. That's what you want to see. The code is successfully generated. So now we hop into the IDE. Anyway, go to File, Open Projects from File System. Right, now select your directory which it's saved under. Sorry, I just want to interject here. I ran into a small error. So when I tried to run that script, I was getting errors and the startup code was opening, which I've never had before, which is weird, to which I realized I've had both IDEs installed, so I had 1.18 and 2.20. So when you have this, I think code gets saved to the wrong places, the wrong addresses, and this code will come up. I fixed it by just deleting the old one and using the new one, and I did start again just to eliminate all the errors, and it did work. So if you do get an error which is like halted at main or halted at a breakpoint, make sure that you have the latest IDE and you don't have any older versions installed on your computer. So we're here in the new version now, and I've already added the line of code that you need to add in user code begin 2, and I've added this line of code here to run the onboard LED, which will be LD3. And so now we're going to plug it in, and we are going to see how it works. I'm going to just change this because I already flashed it. Just doing this to show you. I want it so you can see the code that's running now. It's blinking, and you should see it blink. We'll go a little bit faster, so you should see it blink a lot faster. All right, so now if we go to run as, we'll get ID application, then we'll run it. Okay. You can see no codes at the moment. See it. There we go. It's flashing. I hate how it's not focused. I'm so sorry. There we go. Look how quick that LED is going now. Lightning fast. Okay, and that is that. Pretty much. Okay, so make sure you just have the newest IDE and it will work. All right, it's worked. So we have it hooked up to the oscilloscope on pin D1. Okay, let's have a look here. We're getting 100 kilohertz, and then that's the board there. So we have, so we have this hooked up to D1, and the ground probe, and then power, and then yeah, we got the flashing green light like we coded it to. These are the equations I was talking about if you want to adjust frequency and duty cycle. So here we have PWM frequency, we have our prescaler, and have our auto reload register. You don't want to touch the prescaler, you just want to adjust the auto reload register to get your desired PWM frequency, and your timer frequency is going to come from the clock map that we saw, which was 32 megahertz. Okay, so this equation down the bottom here is set up so that you can input your PWM frequency that you desire, and you'll get your auto reload register value. This one is 319 because, you know, we have 32 megahertz. We want 100 kilohertz, and our prescaler is set to 0. So we get 319. And then moving down the bottom, our duty cycle is a bit more simpler. Our CCR stands for capture compare register, and that is going to be our value that we want to set our duty. So our auto reload register we got from the above, which is right here. So you plug that in, and then this is the equation that you want. So put your duty cycle that you want. For me, it was 25%, and then we got a compare capture register value of 80. So that is how you just select what frequency and duty cycle you need.